I'd like to review a problem from Practice Exam 1. It talks about a livestock company that reports a mean weight of young steers at 1,120 pounds and a standard deviation of 82. Based on the model, what percent of the steers weigh over 1,250, under 1,150, and between 1,100 and 1,200 pounds? For each part of this problem, I'm going to use StatCrunch. But before I use StatCrunch, I'm going to have to calculate some z-scores. Here we go. So here is the mean and the standard deviation for the problem. First, we calculate the z-score for over 1,250. Then the z-score for less than 1,150. And then two z-scores, one for between 1,100 and one for 1,100 rather, and one for 1,200. So we come up with some z-scores. And then we're going to go back to our problem. And we're going to pick StatCrunch. And under StatCrunch, sorry, I have to we're going to pick calculators, and we're going to pick normal. And then first we're going to leave a mean of 0 and a standard deviation of 1. We're going to change this from less than to greater than. And our z-score was 1.59, and we're going to have 1.59. We're going to hit compute. So the probability is 0.0559, and they want this as a percent, so that would be 5.59%. So let's leave that and go back to our problem. Go back to our problem and enter 5.59%. Part B, we're going to have to go back to StatCrunch again, and we're going to be picking calculators, normal, and this time our z-score is 0.37, and we want less than 0.37. So we're going to hit 0.37 and then compute. And the probability is 0.644. So as a percent, that's going to be 64.4%. 64.4%. And then we're going to, for part C, we're going to have to pick StatCrunch again, and we're going to have to do stat calculators normal. And this time we're going to hit the between button, and between two z-scores, one is minus 1.24, and the other is positive 0.98, and we're going to hit compute, and as a percent, that would be 72.9%. Get out of this, and we're going to do 72.9%. And that's the end of that part of the problem. Okay, one more problem. We're looking now at a school designing furniture for elementary school classrooms, and they want to decide what size desk they should have. The height of children are normally distributed with a mean of 39.2 and a standard deviation of 0.6. I'm going to zoom right in on part B. The company wants to develop furniture that will accommodate the middle 60% of the kindergarten kids. So we're going to have to work this problem backwards. We're going to have to go into StatCrunch, and we're going to have to find the z-scores that mark the middle 60%. So we're going to go to StatCrunch, Stat Calculators, Normal, and now we're going to pick the standard, and we're going to pick between, and now we're going to plug in the middle 60%, 0.60, and please give me the two z-scores that mark off the middle 60%. And they are minus 0.84 and positive 0.84. We're always going to round z-scores to the nearest two decimal places. So we're going to get out of this, and we're going to do a little computation. The middle, this should say 60%, excuse me. The middle 60% is marked off by the two z-scores, positive and negative 0.84. Well, what about negative 0.84? What is the height corresponding to it? The height minus the mean divided by the standard deviation is minus 0.84. So we have a tiny bit of algebra. We need to cross multiply and then add the 39.2 to get a height of 39.6. What about the height corresponding to 0.84? Again, cross multiply and then add 39.2, and we get a height of 40.8. So 39.6 and 40.8 mark off the middle 60%. And there we have it.